Hello guys, this is Saddam Leonardo Cap. Welcome to the boring channel. In this video I am going to prove that curl of electric field is going to give you 0. Before I am going to start, if you remember that if you have some kind of point charges, the electric field is radially outward side. So in some sense the point charge is assumed to be spherical, and now what I am going to do is that electric field for their distribution, this can be given out by this guy. Now r square is that for some point, suppose you want to find this distance, that is the r is the radial distance. So as my point charge is spherical kind of symmetry, now what happens is that if I know what I can write for the length element in spherical polar coordinate system, that is drr hat, r d theta theta hat, r of sine theta, d phi phi hat. Now what I'm going to do is that, for an example, I want to find what happens to the electric field if I will integrate over any kind of path length. Okay, and the thing is that this path length must have to be close. Well, now suppose I want to find what happens to the RA to RB, and I want that this path length has to be closed. So the path anywhere, if I'm starting from here, this has to go like this and go from like here. Okay, so wherever I'm going to start, I will finish there. Now what I can write is that since here is r hat and this is in dot product, this is going to be dot product with this guy and this guy. These all are mostly perpendicular to each other with r hat, so this guy contributes nothing. So I am remaining with 1/4 pi epsilon is simply the constant. I am writing it here, and hence I will write this guy only. If I will integrate, this is going to form RA supposed to RB, so what I will left with Q over R, RA to RB, and this the integration has been done, so I won't do anything right test. Well, I can write here simply Q outside, that is my RB, my R's of A. When the path will close, the close means if you are starting from here, you go all the round where and again come to this point. So from where you have started, you will end up from there. Then it will be called as closed path. So if I am starting from RA and I will move all the way, I will end up to RA. So in some sense my RA and RB both are equal. So I can do is, since 1 by RA and 1 by RB will equal, cancel out each other, and so we have seen that for closed path the line integral will be 0. Now how this is related with electric field? So there is one theorem is called Stokes theorem. Okay, Stokes theorem implies that suppose you have any kind of vector field and you are taking the line integral over any closed path, will be same as if you are taking the curl of that vector over any closed surface. Now what does it mean by curl? Curl suggests that if you are having some kind of a vector, then how much it is curled up, how much it is twisted. The twisting of any vector field is going to give you by the curl. The analogy is like that. Suppose you have some kind of a surface, okay, any surface which is enclosed by the boundary. You cannot have any surface which is not have any kind of boundary. Suppose I am saying that there are some kind of vector fields which are having the curled up like that way, and each and everything having same orientation like that. These vector fields are curled up. So what Stokes theorem says that you don't have to integrate over entire surface. What you can do is that you take the whole bunch of vector and you will just integrate over the boundary, and this will be same as the how much the vector has been twisted over the surface. So this is the beauty of Stokes theorem, that you don't have to produce any kind of curling of some kind of a vector. You just understand that, okay fine, this thing is happened over there, and you will just integrate over the boundary and your job is done. Similarly, what we can do is, since my E dot dl is going to give you 0, I can write it simply curl of E dA is equal to 0. Now since integral is my integral is vanishing, and so I can write is curl of electric field will vanish. This is the very simple idea. So curl of electric field is vanish. What does it mean? It means that over the surface of any kind of boundary, over the surface, the electric field is not twisted. The meaning is that if you are having any kind of charges here, so if you plot any surface, the electric field is readily outward. You will never see that electric field is twisted. So there is no any twisting of electric field here. That's why the curl of this electric field, whatever the surface it is, the surface from where it is coming outside, it's not twisted anywhere. Hence the electric field is, the curl of electric field vanishes. Now one more thing I can describe you here, that you know the magnetic field, what does give you? The curl of magnetic field will going to give you the current. I am just exploring here simply the Stokes theorem and tell you what happens. Whenever you have having the current, the the magnetic field is perpendicular to that current, and magnetic field is always forms in a closed loop. You will never see any kind of magnetic field which has the electric field characteristic. It means that it is coming out from one point to another point. No, the magnetic field always, if it is coming out from one point, it will again ending up that same point. So you don't have any specific point that this is the point where it is originated. And this fact shows that there is no any existence of magnetic charge. Unlike electric charge, in electric field what happens, there is a charge and from which the electric fields are emerging out, but you don't see any kind of a magnetic charge where it is responsible for the magnetic field to coming out. That's why there is no any monopole exist in a magnetic field. There is a monopole in electric field, but there is no any monopole in magnetic field. Well, now what does it describe is that, so suppose if I have any surface, curl of magnetic field says that, for an example, it does carry current. Okay, current, it means that J is nothing but I over A, the current per unit area. So what happens that this current is on the boundary. So what happens that all the magnetic field will be like that. Okay, all the magnetic field is just like this way. So if magnetic field is like that, the current will be perpendicular to each other. So the magnetic field is just like that. So I can easily write it there. The magnetic field forms a closed loop like here. The Ampere's law will give you what happens at Ampere's law. It says you that if you are integrating your magnetic field over any closed loop, it will simply give you the current. So what happens that all the magnetic field which is bounded by the surface, bounded by any kind of region, that is any kind of a closed path, will give you the current that is encloses the surface. So inside the surface, all the magnetic fields are curled up, or all the magnetic fields are formed in a closed loop. You just integrate each magnetic field, or you just integrate each magnetic field, curl up the magnetic field, and you will integrate over the entire surface. Will be same as if you are integrating the whole magnetic field over the boundary, and you will get the current. Okay, what is the direction of the current, you will easily get. So this is the beauty of that. Okay, fine, your current is like that way, the current is going this way, all the magnetic field lines are just like here. So the magnetic field lines, so you will just whatever there is a surface, there are too many surfaces, this and this and this and this thing. So you simply just integrate the boundary of magnetic field, and you will get the Ampere's current law. And from here you can easily say that, since we can always write that, okay, curl of magnetic field is equal to mu naught I, and mu naught I can be written as mu naught J dot dA. Sorry, I'm left with here dA. Now the integral is equal, what I can do is write curl of B is equal to mu naught J. and here is your differential form of Ampere's law and integral form of Ampere's law. And here we have described that what is the meaning of that curl and how your Stokes theorems actually work. The idea of Stokes theorems is very simple and elegant, because in so many time you cannot work out this guy, so you will always have integral in a basis of a line integral, and it has so many advantages in differential form. I will describe it in my later video.